This is going to be part one of a several part series on combining your ramps with your Duo. And this particular video is going to deal with the background, what you can expect to work, what you can expect not to work, and what some of the safety concerns are. And I'll get to the actual hardware modification in the next video, which is recorded, but I have to find time to edit it, so I'll get that up as soon as I can. Note, this is a long video and there is a lot of nerd babble in it, but I wanted to include as much information as possible, so I don't expect you to watch the whole thing, but try to watch the safety sections, please. So, you want to hook a ramps up to a Duo, do you? Well, here's the deal. You're getting into a little bit more of an involved process than you think you are, so I'm going to be calling this video How to Duo Plus Ramps and Why You Might Not Want to. Now, let me say ahead of time, this is a fairly advanced process, and there are safety concerns for you, your property, and your equipment. I take no responsibility for anything that happens. I have done this modification several times in several different versions myself, and as you can see, I managed not to burn myself down. But regardless, I always have one of these next to my printer anyway. But whatever your results are, we understand that whenever you're talking about hacks, there's inherent danger, and you have to butch up and take responsibility for yourself and not blame it on me. That being said, the hacks do work, for the most part. And if you decide to use Marlin, then the RepRap discount full graphics display is already supported in the profile, so that makes it very convenient. That is using software SPI. I did hack mine to use hardware SPI for at least the SD card, but that's optional. And I stripped everything down to the bare bones, and I did all of these mods from scratch with this gear right here, taken right out of the package. So I at least know that if you stick with me through the end of this series and you use similar gear, then you should have a working setup at the end of it. Now, this is one of those videos where I've been debating for a long time whether or not I should do this. Because there's review videos, there's how-to videos, there's evaluation videos, there's modification videos, and then there's straight-up dirty hacks. This definitely falls into straight-up dirty hacks category. Now, that being the case, since it's a very niche thing, you're not going to find a whole lot of support online for it. And that's one of the things that kind of tipped me to the side of doing this. Because while there are a decent number of posts online that'll at least show you how to do the mod, they kind of leave it at that, don't give you a lot of background information, and, you know, a lot of those forum trolls will kind of make you feel like a dick just for asking. That and the fact that one of my Patreon subscribers bribed me into doing it, and he demanded that I wear my silly hat. Now, the reason that I was hesitant to do it is, A, because of the fact that it is a hack, you do have potential of screwing up your board, and there's not a lot of support elsewhere for getting your peripherals working right. The second is I don't necessarily want to become a resource on how to get things working with this hack that I'm iffy about to begin with, because you could put out a video that's just like how to do this thing, and then everyone's like, okay, I did the thing, now how do I get it working with X, Y, and Z? And I'm like, that's not what I did, I just showed you how to do it. But the most important issue that made me hesitant was that there's kind of a safety issue involved, and I will get into that. But if you are very comfortable getting around your firmware, if you're comfortable with a soldering iron, and preferably if you can read a Gerber file and a schematic, and you really want to just give this a try, then I'll show you how to do it. So I did a little bit of research in the firmware and poked around the internet, looked at some schematics, and I came up with the setup that I thought would be the easiest to do this modification on. I took a Ramps 1.6 board, because I knew that at least the bed MOSFET would be okay for a hot end. I don't think it'll be okay for a bed, so don't do that necessarily. And I knew the other two FETs on there would be really no good for anything. But what I did was I swapped the bed MOSFET for the hot end so that I could at least get the hot end to work without having to desolder any FETs. Also, I didn't use any fancy schmancy drivers. I just used regular old Allegro A4988s. For display, I used a cloned RepRap discount full graphics smart controller with SD card. The end stops are just the standard mechanical RepRap end stops, and I'm not using anything fancy, just standard thermistors, not thermocouples, and I'm not using a Z probe of any kind. And just as a bonus, I converted it to 24 volts, which is extremely simple with these types of boards. So there you go if you want to do a build along at home. So here's the whole process. You ready? Cut the pins that supply 5 volts from your Arduino to your RAMs. Instead, wire your 3.3 volt rail to your RAM so your 5 volt becomes a 3.3 volt rail. Set your Duo firmware all up in platform I/O. Upload it to your board and make sure all of your peripherals are compatible with 3.3 volts. That's all. Bye. I'm just kidding. I'll tell you how to do it every step of the way. Now, I'm going to show you the way that I think is the simplest and the least destructive. But since this is a dirty, stinking hack, there are virtually infinite ways to do it. And that's where some of the problem lies. And all that depends on what you're going to be plugging into it. So for example, if you're wondering how to get a particular type of LCD screen working, you can modify the hack so that you're not cutting the traces or the pins to a particular 5 volt rail and a header, and then you can run a bypass to give yourself the 5 volts that you need to run that peripheral, etc., etc., etc. So okay, intro to the hardware. Let's talk about what the difference between the Mega and the Duo is, practically speaking. We know it's an 8-bit processor to a 32-bit processor, and there's a much higher clock speed and blah blah and all that stuff. But practically, what is the difference going from a Mega to a Duo? Now, I touched on this a little bit in my ramps wrap-up video, where I gave myself a couple minutes to rant and rave about what Arduino did with the Duo, but let me get into a little bit more depth here for you. First off, the Duo operates on 3.3 volt logic. Now, if you don't know what that means, you have your power to your board that powers all of your peripherals. You have your stepper driver power, which is usually much higher voltage, and then you have your logic voltage power. Now, depending on what industry you're talking about, you can have different logic voltages, and that's the voltage that like your gates and your digital peripherals and all that stuff is going to work off of. Now, there are a few things even using the Mega that are 3.3 volts. For instance, your SD card reader that works off of SPI. Those are all 3.3 volts, but the panels that we get, like the rep discount displays and things like that, they have an onboard regulator that knocks the voltage down from 5 to 3 just for the purpose of your SD card, whereas the rest of it all runs off of 5 volts. So the problems when switching to 3.3 volt logic are twofold. One, your logic has a high trigger and a low trigger threshold, and they're usually a percentage of your total voltage referenced to whatever your VCC is. So if you're trying to send a signal to an input that's expecting 5 volts, but you're only sending it 3.3 volts, you're going to be able to hit your low threshold just fine, but you might not be able to hit your high threshold because of the ratio that is below your voltage input. Usually you're okay. I've been doing this forever, and there are ways that you can trick the 5 volt input to use 3 volts. For example, using one diode drop from your 5 volt rail to your 5 volt component, usually that'll make it trigger with any 3.3 volt input. So again, that's not as much of a problem. What's a bigger problem is if you have a component that runs off of 5 volts and it's sending a 5 volt logic signal back into a 3.3 volt input. If you do that, you're going to blow up your 3.3 volt input. And if that 3.3 volt input is attached to your microcontroller chip, you're going to pop that. So you have to either avoid anything that's going to send 5 volts back in, just don't use it, use 3.3 volt stuff, or you need to drop that voltage by certain means. You can use a voltage divider, a passive or active clamp. Sometimes just a resistor will drop enough if you know what your current sink is going to be. Or you can use active logic shifters, either one way or two ways. But the big deal with the Duo is it uses a SAM series ARM chip, and they don't have a lot of 5 volt tolerant pins, if any. I think they might have a couple, but not enough to really help us out. Which is one of the things that annoyed me when they went to the Duo, because they stuck with Atmel CPUs, which makes sense. They had a relationship with those people. They made all the Atmega chips and all that stuff, the 328s and the 168s. But there are plenty of 32-bit chips families out there that have 5 volt tolerant pins on nearly every pin. They decided not to use those. So that makes for a lot more anguish and gnashing of teeth and work. But anyway, we'll deal with that when we get there. The next problem is that there are no SPI pins on your digital header. That's the, wait, I have a board here. This bottom header here, these are your digital pins. It's upside down, but you'll see that says digital on it. Now on the Mega, these first few pins are SPI, and you also have a second SPI bus on your ICSP header. That's your programming header. On the DUA, there is no SPI on your digital header, which means that any of your adapter boards that are going to be dependent on SPI down there, for example, the SD card on your control panel, those aren't going to work because your ramps board takes this pin on the bottom header and breaks it out to one of the aux headers on the side, right here, aux 3, and then that's where you get all of your SPI output that is going to run your SD card. Some displays also use a shared SPI hardware bus for the display as well. They run it in like 3-wire mode, I think. That means those displays won't even work. Now, there are, of course, ways around that, and there are some of those baked into particular firmwares, but again, those are things I can't cover individually because you have to take it on a case-by-case basis, depending on what display you have, what libraries it runs off of, what modifications have been made to those for each particular firmware, what your adapter card looks like, which pins they set it to on their particular adapter card, and this is very important before you ask me any questions about this, whether or not it's open source. Because I get a lot of questions like, how do I do this with that board? Or what do you think of this other board? And I'm like, I don't have the schematics. I don't know anything about it. Looks like a nice shiny piece of plastic, but it's the same thing with displays. If they have proprietary connectors and they don't tell you what chip driver they're using, and you don't know what the pin designations are, and you don't know what the power handling is, and I don't know if it's shared SPI bus or if it's I2C for the monitor, or like 4-bit, 8-bit mode, and then the SD card is buffered 3.3 volt and it's on the EX1 header as opposed to the EX. I have no idea. There's no way I could possibly know without being a mind reader. Or having the board in front of me and taking a multimeter and beeping out each of the pins and writing down a map for it. But regardless, no open source, there's no way I can just pull up a file and know how to wire it. So that all just means when you're getting to the part where you're wiring up your SD card or like a pre-made panel, rip-rap discount, like I said, or something like that, you're going to have to do additional hacks to either the ramps, the panel, or your adapter board to get that to work right. Next difference, the DUA doesn't have an EEPROM on it, where the Mega did. So if you're one of those people that likes to save, like tweak changes on the fly and save them into your EEPROM, instead of reprogramming your firmware and reflashing your board, you're out of luck unless you wire your own EEPROM unit to it. And they're really cheap, and there's probably pre-made little plug-in boards that are available. Usually they work off of the I2C bus, which is a 2-wire bus, and you know, you have your 2 wires and your ground and your power. You plug it in. Marlin, I know, is already set up to handle that kind of stuff, so all you have to do is enable it and you're good to go. If you don't use your EEPROM, it doesn't matter. I don't really use my EEPROM because I have my printer right next to my computer, and I can always just reflash the firmware with whatever changes I wanted. Next problem, there are fewer analog pins. Usually that's not going to be an issue, but it might depending on what you're going to be plugging in and out of it, what you're controlling and all that. You also have less overall current with the DUA than you did on the Mega. The package current for the Mega was around 200 milliamps. The package current for the DUA is 130. So if you'd ever popped your Mega because your peripherals were drawing too much current and you plug that into the DUA, it's going to pop it that much faster. It also uses microUSB connectors, and there are 2 connectors, one native USB, one programming. We're going to be mostly using the programming port, but that's just something to think about, because if you order one of these, you may or may not get a micro USB cable. And here's a warning ahead of time that might save you a lot of anguish. Many of those micro USB cables are just used as cell phone charger cables, and they don't have the 2 data lines attached. It's only the power lines. So you will plug it into your computer, plug it into your Mega or your DUA, and it'll power up and you think everything's okay, but you won't be able to upload anything. It'll say like no port available or whatever, because there aren't actually any wires connecting the data port. So make sure that's working before you get all frustrated and wonder why your board isn't connecting. Now, that was just a taste of things that may or may not work. I think I hit some of the major areas, but there are other little mutant things here and there that will or will not work, and hopefully I can touch on some of those in the hardware section, and I'll let you know. Okay, so those are your differences. Now let's talk about, after you do this modification, what definitely won't work out of the box. This doesn't mean that you can't hack it into working. It just means what's not going to work right out of the box. First off, any stepSticks that don't generate their own logic voltage or can't accept 3.3 volt logic voltage are just not going to work. Texas Instruments DRV8825s, they will work. They generate their own logic voltage and they're compatible with 3.3 volt logic. Allegro chips, the A4988s and the H4988s, they will work, but their logic has to be 3.3. The fancier Trinamic drivers, they'll work. They generate their own logic voltage. That's not a problem. And what I know definitely won't work are some older Allegro stepSticks and TMC 2100s. Only some of them, because they came in either 5 volt or 3.3 volt logic. So many of those aren't going to work, because I think the bulk of them that were sold were the 5 volt logic chips. The ones I have are 5 volt logic chips, and they definitely won't work. The other chips, the 22.8s and the 2130s, they should work fine in standalone mode. In UART SPI mode, you're going to have to deal with the peculiarities of the SPI versus the software SPI, hardware SPI, and how all that configuration works in Marlin. And that's beyond the scope of this video, so I'll just give you a little heads up where that might take a little massaging to get it to work. Which leads me to any shield or adapter card that uses SPI and expects that to be on the AUX3 header is not going to work without modification. So for example, the smart adapters that come with your, well, I can't show you, it's plugged into stuff, that adapt this little end to your RepRap's, full graphics control or character control panel. That will not work out of the box the way it's intended to. You can software SPI and you can get it working, or you can move some of these pins around, cut the pins on your ramps board, run a wire from your ICSP header on your DUA, and use hardware SPI for at least just the SD card, because software SPI is a whole lot slower. But this video is not about the displays, it's about the board itself. So anything that requires 5 volts power on your shield won't work with certain ways of doing this mod, because you will be running 3.3 volts on the 5 volt on your ramps board, which means something like an LCD display that uses a 5 volt backlight won't light up. Or you can modify your board so that you have 5 volts on very particular headers and 3.3 volts on the others. That's not a mod that I'm going to show, because that would be something you would only do if you were specifically trying to make it easier for you to use one type of peripheral board without having to run external, jumper wires and solder them, around. But if you do that, you have to make sure that you're not feeding any 5 volt signal back into your Arduino, which might fry it. Next, the pins on your Arduino DUA can source and sink less current than your Mega did. So you have high current and low current pins. The high current pins, you can source 15 milliamps and you can sink 9 milliamps. The low current is 6 and 3 milliamps. So for example, if you had on your Mega an LED that was hanging off one of the GPIO pins, and it was happily sucking down like 17, 18 milliamps when you lit it up, that's all well and good on your Mega, but if you just plunk that onto your Duo, you're going to pull too much current from that pin and probably fry your processor. Okay, the safety concerns. Most important one, the MOSFETs that are on typical ramps boards won't even work properly at 5 volt logic, let alone 3 volt logic. So your MOSFETs, no worky, 9 times out of 10. Now, I already told you that the board I'm using, I did make sure there was one MOSFET that would work, so you could at least try getting a hot end going. I don't know that I trust it for the bed, but the rest can be replaced eventually, and you can reassign the pins back where they belong. As an example, this is what your ratio of RDS on to gate to source voltage looks like. And as you can see from the orange circle and arrows, at 5 volts, we're pretty good. We're about 3.5 milliohms. and that's a real low RDS on. But if you look at the 3.3 volts, it's off the charts. That's not even something that they have a measurement for, and we have no idea if it's actually going to behave or not. And this is a data sheet for one of the better MOSFETs, just to give you an idea. And this is what I was talking about earlier, where there's a practically infinite number of variations on this modification, because it is very possible to use the onboard MOSFETs, regardless of what they are, if you use a logic level shifter like this little gizmo that I took a picture of on my desk. But that requires us to cut traces and solder jumpers, so I think it's a lot easier to just replace the MOSFETs, which is what I'll be doing in this. And I'll definitely get into more of this stuff, including external MOSFETs and that type of thing when we get to doing the hardware modifications. I just thought I'd toss this out there ahead of time so you know what's coming up. Here's a list of MOSFETs that are known to work in both surface mount D-squared 2-pack if you're using like a RAMPS 1.5 or 1.6, and TO220 through-hole package if you're using a standard RAMPS board, as well as the corresponding prices for one piece on digikey.com. So what happens is our MOSFETs don't switch on completely. They end up having a very high RDS on if you get any current flowing through them at all, which means they're going to heat up a whole lot as you pump current through them. And then we're back to our typical RAMPS MOSFETs melting down and bursting into flames behavior, which is bad. For details on how this works, check out my RAMPS, I think it's 3 of 5, 4 of 5, 2 of 5, I don't know. One of the RAMPS videos deals with just the MOSFETs. That goes into all the math that you need to know. And then I have another 5-minute data dump video on how to select MOSFETs using a parametric search on digikey.com, so you can find ones that work better. But here's a selection of MOSFETs that are known to work, at least somewhat. I recommended the IRLB3034 in my previous videos. That's what I use. Also, some MOSFETs, or some RAMPS boards come upgraded to IRF3205 MOSFETs, and those are reported working. I have not tried them myself. But because of variation from one component to another, it's very possible that they, even though they may turn on, they may not be able to handle a whole lot of current anywhere near what their rating would suggest. And then the IRLB8743s are what are used on like the RAMPS FD board and a couple other shields that use the DUA. They are also known to work at 3.3 volts. I have not measured their RDS on though, and I don't know how much current they can handle. But that is something you could probably look up on a forum that has to do with the RAMPS FD or something like that. Second, the power-up sequence and initializations for the Duo are slightly different than the Mega, and there's a possibility if things go wonky that the MOSFET pins will latch into a high state, leaving the MOSFETs in a permanently on state. So keep a close eye on your board anytime you make a firmware change to make sure nothing goofy happens and they get caught latched up. Now, if your RAMPS follows the schematic, the LED lights should come on if there's any power going through the MOSFETs. So if you see like your bed MOSFET light lit up when it's not supposed to be, it's probably in the on state, and do a hard reset of the board and make sure your firmware uploaded properly. So that's it for this first part. Stay tuned for the second part where we go through the actual hardware modifications, and then the third part where we do the software, etc., etc. Thanks for tuning in. As always, if you're into these videos and you want to see more, I do have support links in the video description below. Until I see you again, get out there and make something awesome.